In this video, we'll be solving this integral. So there's many candidates for u substitution, but I'm going to let u be whatever's inside the natural log. So for this example, it'll be the 6th root of x plus 1. So then the derivative will be 1/6 x to the negative 5/6 dx. And then from there, I can solve for dx. I don't have the steps here, so let's go over it. So starting with du is equal to 1/6 x to the negative 5/6 dx. I multiply both sides by 6x to the 5/6. And notice that if I solve for x to the 1/6 here, that's just going to be u minus 1. That means x to the 5/6 will be 6 times u minus 1 to the 5th power. Okay, and that's how we got dx. Okay, so we got dx. We know what inside the natural log is. Let's figure out the rest. Okay, let's get the cube root of x first. So I know that u minus 1 is the 6th root of x. That means if I square both sides, I get cube root of x. And if I cube both sides instead, I get square root of x. Okay, so now I have everything in terms of u. So let's plug it in. I have ln of u, and then 6 times u minus 1 to the 5th du, and then u minus 1 cubed plus u minus 1 squared. Okay, at this point, I notice that the denominator has factors of u minus 1. So you want to pick the smaller factor. Is it a cubed or is it squared? Well, the smaller of the two is a square. So you want to pull out a square, and then you'll have u minus 1 and then plus 1. So then the u minus 1 squared is going to cancel, and you have u minus 1 cubed at the top. And then we'll pull out the 6 in front to get this. And now you have minus 1 plus 1. Those are going to cancel. So you just have ln of u over u times u minus 1 cubed. I'm going to expand the u minus 1 cubed into u cubed minus 3u squared plus 3u minus 1. And now I'm going to divide everything in the parentheses by u. So that's just u squared minus 3u plus 3 minus 1 over u. And then we're just going to multiply that by the natural log. Okay. Next step, we want to distribute the natural log to get this. And this point, it's a bit frustrating because you need to integrate each one of these. Now, I will integrate the first, second, and last, but this one, I'm going to use the fact that the integral ln of u du is just u ln of u minus u. Okay. So if you're interested, you would just do the integration by parts and just let f be ln of u and dg just be du. And then continue from there. But yeah, we'll just take it for granted. We'll just say this is the formula. So the next couple slides, I'm going to show you how to integrate those three. Starting with u squared ln of u, we're going to let f be u squared. So then the derivative of f is 2u du. That leaves dg to be ln of u du. And then the antiderivative is that. So then you just multiply fg minus integral g df. Okay, so I'm going to use a trick here. I'm going to still have the integral u squared ln of u du here. And then I'm going to have the rest over here. But notice here that you have an integral u squared ln of u, integral u squared ln of u. I can add 2 integral that to the other side to get 3 u squared ln of u. Okay, that goes away, and I'm just left with the negative 2u squared. And because you have 2 negatives, it's going to become a positive. Okay, so then I'm going to divide everything by 3 because I just want only the integral of u squared ln of u. So divide everything by 3. And then I just integrated 2u squared as 2/3 u cubed over 3. and I multiplied top and bottom by 3. So that went over here. So that was 3u squared, or 3u cubed rather, because you have u squared times u is u cubed, and then 3 times 2/3 u cubed, which with some cancellation from the u cubed, we got negative u cubed, right? Because u squared times u, that was negative u cubed, and that was actually 3, and then added that 2u cubed. So yeah, there were a couple steps skipped over here, but this is our final answer for this integral. And so we're going to use that later for the solution. The other integral now is u ln of u du, and this we're going to do similar to the other slide. We're going to let f be u, and then dg is ln of u. So I'm going to keep the original integral on the left here because I'm going to add it with this integral. So then we'll have 2 copies of that. And now this 2 negatives becomes a positive, and I'll divide both sides by 2. So here, this is the antiderivative of u du. And so I multiply top and bottom by 2 because I want to get rid of this denominator of 2. And so I get 2u squared ln of u minus u squared over 4. Now the last integral we need before we can solve it is 1 over u ln of u du. So I let v be ln of u, which means dv is 1 over u du, and that just transforms into the integral of dv over v, which is the natural log of v plus c. And so v, we said, was the natural log of u. Okay, so that's just natural log of u plus c. Okay, now let's put everything together. This was from a couple slides ago. We showed how to find these integrals, and this one we just assumed. We just used this fact. Okay. So we'll replace everything. Now substitute back what u was, and that is our final answer.